In this lesson we're going to continue to look at condensation polymers. Last lesson we looked at polyamides. In this lesson we're going to look at polyesters. Now polyesters are made by combining a dicarboxylic acid with a diol. So we have the dicarboxylic acid or diacid with the alkyl group in the middle, and at either end of the alkyl group we've got the carboxyl groups, and with the diol at either end of the alkyl group we've got the hydroxyl groups. Okay, so now this shouldn't surprise us because we remember that esters are made from carboxylic acids and alcohols. Now in this lesson we're going to focus on a polyester called Terylene, and so let's look at the monomers that are used to make Terylene. So for the diacid we're using benzene, 1,4-dicarboxylic acid. Okay, so the benzene is this hexagonal arrangement of carbon atoms here in the middle. So you've got 1, 2, 3, 4, 5, 6 carbon atoms, and the carboxyl functional groups are positioned at carbon atom number 1 and carbon atom number 4. And on the other side we've got the diol, and in this case we're using ethane 1,2-diol. Ethane is the 2 carbon atom chain with the hydroxyl functional groups at either end. So in this course you do not need to know how these are prepared, and you do not need to know about the manufacturing processes that are involved. We're just really concerned with how these link together. And so let's just look at that. So we've got the diacid, then the diol, then the diacid, then the diol, and as each of these monomers comes together a water molecule is removed. So we're going to take the OH from the carboxyl group and the hydrogen from the hydroxyl and then repeat that, etc. So the formation of this chain is going to result in the production of water. Again, that's typical in condensation polymers, and we're going to get the following polymer chain produced. So you've got the carbon oxygen double bond here, and then the oxygen from the hydroxyl group here, and because it's this COO structure which is characteristic of the esters, this is known as an ester link, and so this type of polymer is known as a polyester because it uses the ester link. In just the same way, the polyamide is known as a polyamide because it uses an amide link to join the polymer units. Okay, and just representing this with our little symbolic diagram that we used in the previous lesson, we're going to represent this alkyl unit and the benzene unit with a rectangle. Okay, and that gives you a somewhat simpler diagram representing this polyester chain with the polymer units being joined by this characteristic ester link. Okay, so this is an example of a polyester.